Okay, so in this video I'm going to take you through example 1b, and it's asking you to calculate the acceleration at 10 seconds on this graph. Okay, now this is quite a challenging question, so but once you know how to do it, it's very straightforward. So initially you want to identify where 10 seconds is. Well, there's 10 seconds, so that's the point on the graph there that we need to be looking at. Now, to calculate the acceleration, we know that the gradient of the graph is equal to acceleration. Okay, now the thing is here, the graph is not a straight line, it's a curve. So because it's a curve here, what we have to do is draw a tangent to the graph. Okay, now you may have talked about tangents in maths, but you've got to draw a tangent to the graph, and the whole point of this tangent is that it's the right steepness. The steepness of this line has got to be just right, okay, so that it's an estimation of how steep the gradient is at that particular point there. So this line that I've just drawn is a tangent to this curve, and it is supposed to be at just the right steepness to estimate how steep the graph is at that particular point there. Okay, or perhaps not estimate, perhaps the wrong word. This line is the exact steepness of the curve at that point there. That's what we're hoping to achieve. Okay, so once we've drawn our tangent, so just to recap, you've got to make sure the tangent is exactly the same steepness as the gradient at the point that you're looking at, which is this point here. Okay, once we've drawn our tangent, we can then calculate the gradient. Okay, now to do this, we're going to draw a gradient triangle. Okay, so this is my gradient triangle here. Maybe I should have done this in red perhaps, but there we go. Okay, so this is my gradient triangle over these areas here. Now, the gradient is equal to change in y divided by change in x. So my change in y here is equal to, well, my final value of y is here, okay? That's my final value of y at this point here. And that is equal to 11, 12, 13. So it's 13 meters per second, and down here I've obviously got 0 meters per second at my final point here, because these are the 2 points that we're using to represent to measure our gradient. So the change in y here, this section here from the initial point up to the final point, is 13 meters per second minus 0 meters per second. Okay, it's your final velocity, take away your initial velocity. Okay, that's the change in y. Now the change in x is, well, this is 5 seconds, and up here this is 26 seconds. So as I go from here to here, the time changes from 5 to 26. So my final time is 26, my initial time is 5. Okay, so it's 26 minus 5. So 13 minus 0 gives me 13, 26 minus 5 gives me 21, and if you calculate that, that should give you 0.62. Now remember, the gradient is the acceleration, so it's meters per second squared. Okay, so that's how you calculate the gradient of your graph at that point. Okay, so example 1b part 2 asks you to work out the mean acceleration for this entire journey. Okay, now as we know, the acceleration isn't constant. The acceleration is increasing, then it's constant, then it's decreasing. So the acceleration throughout this graph changes because the gradient is changing. We're asked to work out the mean acceleration. So to do that, we're going to draw a line like this. Okay? So because of the symmetrical nature of this graph, this straight line here is the average gradient of this graph, okay? And therefore you can use it to calculate the mean acceleration or the average acceleration. Okay, so let's do that now. So this only works here because this graph is nice and symmetrical. Okay, but we can work out the mean acceleration. So the mean acceleration here is change in y divided by change in x. So gradient equals change in y over change in x, because remember the gradient is equal to the acceleration. Okay, now if you look here, we're starting off down here. So our initial x value, is 0, and our final x value is 30. Our initial y value is 0, and our final y value up here is 15. Okay, we could have your y value down there as 0. So our change in y is equal to 15 minus 0. Okay, because we're starting off down here at 0 and going up to 15. So the change in the y value, change in the velocity is 15. Okay, and the change in x is, you're starting from 0, going up to 30, so the change is 30 minus 0. Right, which equals 30. So your gradient is going to be 15 divided by 30, which gives you 0.5, and the unit is meters per second squared. Now there's another way of doing this as well, and that is that the acceleration is equal to the change in velocity. The mean acceleration is equal to the total change in velocity divided by the total time. So you could do it like this. And that's equal to, well, we know that the total change in velocity here is 15 because we're going from 0 to 15. Whoops. And we know that the time is 30. So it's 15 divided by 30, which again gives us 0.5, and the unit is meters per second squared. Okay, so either way you do that, you're going to get the same answer. All right, there we go. So in example 1 part C, you're asked to work out the distance travelled in the entire journey here. Okay, so in this 30-second period. Now we know that to calculate the distance travelled in this 30-second period, we're going to need to work out the area under the graph. So we need to work out the area under this curved graph. Now that's not straightforward. To do that, really we need to use a mathematical method that you will learn when you do A-level maths. There are other ways though of estimating it, but actually in this example, because the graph is symmetrical, because the curve is a symmetrical shape, we can do this. We can just make the graph a nice straight line like that, and then we can calculate the area under this red line, and that's going to be exactly equal to the area under the black line because of the symmetry. In this region here we're going to be overestimating the area under the graph, but in this region here we're going to be underestimating the area under the graph by an equal amount, so it cancels out. So actually if we just work out the area under this red line, okay, this area here, then we are going to get exactly the distance travelled in this journey. Okay, it's going to be exactly correct. So this shape here is a triangle, so to work out the area we need to use half base times height. The base here is 30 seconds, so from 0 to 30, and the height is from 0 to 15, so 15 meters, 15 meters per second. So it's going to be 0.5 or half times 30 times 15, and that's going to give you an answer of 225 meters. Okay, and that's that one done.